Today we're going to review integers. An integer is 0, any positive number, and their opposites. So looking at a number line, you have 0 in the middle there. To the right of 0 is your positive numbers, 1, 2, 3, 4, 5. The further you move to the right, the larger the numbers get. To the left of 0, you have the opposites of the positive numbers, and that is our negatives. So -1, -2, -3. The further you move to the left on the number line, the smaller the numbers are getting. When you are adding integers, you're going to try to determine, are you adding two integers with the same sign or two with different signs? If we are adding integers with the same sign, in other words, they're both positive or they're both negative, we're going to add and keep. So we're going to add their absolute values and keep the sign we see. So for number 1, -15 and -22 both are negative, so we add 15 plus 22 and we keep the negative sign, so -37. Same with problem 2. Add and keep. Both are negative, so 25 plus 43 is 68. Keep the negative. Number 3. Again, both negative, so we add and keep. 70 plus 32 is 102. We keep the negative sign. When we add integers with different signs, we're going to subtract their absolute values and keep the sign of the larger absolute value. So for number 1, I have two different signs. I subtract 35 minus 16 and I get 19. 35 has a greater absolute value and it was a -35, so it's going to be a -19. Number 2, two different signs, subtract 50 minus 22 and get 28. The -50 has a greater absolute value. It's further away from 0, so I get a -28. For number 3, positive 75 has a greater absolute value, so therefore we would have a positive answer. Take 75 minus 40, we get 35. And for number 4, we have a 65 minus 15 gives us 50, and the greater absolute value comes from the positive 65. The next topic will be subtraction. To subtract integers, you need to keep, change, change. For problem number 1, we would do -25 plus -16. So to keep, change, change, you keep the original number, first number, change subtraction to addition, change the number after subtraction to its opposite. So then you would follow your addition rules from our previous screen. Number 1 would be -25 plus -16. We're adding integers with the same sign, so we would add and keep and get -41. For number 2, would be 43 plus positive 21. That gives us 64. Number 3 is -50 plus positive 30. Now we would be following our rules with different signs. So yes, we will need to go back to subtraction. The greater absolute value comes from the -50, so we would get a -20. It's very important to rewrite it as an addition problem using your keep, change, change rule. Then you only have to remember the two rules that we talked about on the previous screen. Number 4, 85 plus -100. Now we're adding with two different signs. So we want to subtract, keep the greater absolute value, which is a -100, giving us final answer of -15. For number 5, -110 plus -200 would equal -310 because you would add two of the same. Next, we want to discuss multiplying or dividing with integers. When you multiply or divide with integers, if the two numbers you are multiplying are the same sign, or if the two numbers you are dividing are the same sign, both positive or both negative, your answer will always be positive. If you are multiplying or dividing and you have two integers that have two different signs, your answer will always be negative. That rule is always going to exist for both same sign and different sign. If you want to think about it a little bit differently, if you are multiplying or dividing two numbers that are negative, it is an even number of negative signs, therefore your answer will be positive. If you multiply or divide and you have an odd number of negative signs, your answer will always be negative. So if we look at the multiplying problems on the left, I have one negative, that's an odd number, my answer is negative. Then I simply multiply 8 times 21. Or I can use the first rule. They are two different signs, again giving me a negative answer. For number 2, I see an even number of negatives, or I see the same sign. My answer works out to be positive. For number 3, I have an odd number of negative signs, or I have two different signs. My answer is a negative 99. Same rules apply to division. For number 1, I have negative and a positive, so that's an odd number of negatives or two different signs. My answer is a negative 11. For number 2, there's an even number or the same sign, so it's a positive 41. And for number 3, I have two different signs, so my answer should be a negative, and then I simply go ahead and divide. I get a negative 10. For our last couple of screens, we're going to review the order of operations. For that warm-up, if you were to rewrite the following in exponential form, number 1 would be 5 to the 4th power since there are 4 5s. For number 2, it would be 7 to the 7th power since there are 7 7s. For number 3, it would be 15 to the 3rd power since there are 3 15s. Remember that a variable is a symbol, usually a lowercase letter, that represents the value of a variable quantity. An algebraic expression will contain variables or one variable with operations and possibly numbers. Algebraic equation differs because now you should have an equal sign involved. It is stating you have either two algebraic or mathematical expressions equal to one another. Looking at the power 5 to the 4th in the bottom left-hand corner, the exponent is recognized to be the 4 and the base is the 5, just to be familiar with some terminology. Just to review our order of operations, remember parentheses is first, exponents second. Step 3, you want to multiply and or divide from left to right. And number 4, you want to add or subtract from left to right. To simplify a numeric expression, that means you're going to replace the expression with its singular numeric value. In other words, calculate it. So for the first example, we're going to follow order of operations. We're going to do the parentheses. 6 minus 2 is 4. 4 to the 3rd power is 64. Then add 2, you get 66. For number 2, want to be a little bit more careful. You can do your multiplication of 5 times 7 to get 35. But before we can do any subtraction, we really need to take care of 4 squared, which is 16, divided by 2, and that equals 8. So 35 minus 8 is 27. One last definition to review is if you are asked to evaluate. To evaluate an algebraic expression, you will substitute a value in for the variables, then simplify the numeric expression using your order of operations. For problem 1, if a is 3 and b is 4, evaluating 2 times b squared minus 7a, you would need to do 2 times b squared. B is 4, so 2 times 4 squared is 2 times 16. Then subtract 7 times 3. Again, multiplication needs to take place before subtraction, so 2 times 16 is 32. 7 times 3 is 21, so 32 minus 21 equals 11. Number 2, part A, x is 3, so 3 squared is 9, plus 2, and then parentheses would need to be calculated. That 3 plus 4 would be 7. So you would have 9 plus 14, and I did not write 9 plus 14. I apologize. I see a typo there. But you would add 9 plus 14 and get 23. For the last example there, b, x times y should be 12. 12 to the 3rd power is a rather large number. It's 1,728. Then you still need to subtract the 5, so we get 1,723. Please let me know if you have any questions on integers or following our order of operations.